Hi, everybody. This is Mr. Folly, and Happy New Year to everybody. Oops. And welcome to the math part of this. Oh man, does it say 7? I think we're really looking at 6. Pardon me. Particles are really small, and we're going to talk about how particles are grouped in moles and how the math of chemistry really works. So get out your little calculators, your periodic tables, and get ready to rock this new year. Woohoo! Okay, so everything is small, really small. So we're talking about atoms and we're talking about molecules. They're small, really, really, really small. 7E15 atoms in a cell. So just to give you an idea, this 7E15 means I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is that right? Yeah, that many or so. 6.6 E20 formula units, that's like a molecule. In, guess what? A diamond, a grain of salt. Holy cow. Think about how big those are, okay? So this means I have 19 zeros after that. So each of these, a formula unit is, remember, salt is NaCl. So one NaCl bonded together, remember, ionically bonded together, it would take 6.6 times 10 to the 20th of those to form 1 grain of salt. In Indiana, I buy a ream of paper, a gross of bottle rockets, and a pallet of Bondo. Why such large numbered groups? So a ream of paper is 500 sheets. A gross of bottle rockets is 144, and a pallet of Bondo, that's just a big thing that I just try to be funny with. Why do we have such large number groups? Because the items are small. So if you recall that previously we talked about how small atoms, molecules, and formula units are. That meant our grouping should be really big. 500 is a big number. 144 is a big number. So we use a mole in chemistry, and a mole is 6.02 times 10 to the 23rd particles. Okay, adds a lot of zeros. Okay, why do we use such a big number? Because particles are so small. So how many of what are in 1 mole of water? So 1 mole of water is 6.02 E23 molecules of H2O. Remember, a molecule, because it's covalently bonded, it's H2O. We have 2 nonmetals, so it is a molecule. Helium. Helium is an atom. It's on the periodic table, right? And there are 6.02 E23 atoms of He. Now, sometimes you go, how can they be the same thing? Well, if I had a dozen donuts, those are 12, right? And if I had a dozen pencils, those would be 12. So no matter what, a dozen is 12. So look, you can tell a mole of this will be on that. Calcium fluoride, this is a metal and a nonmetal. So we're going to have 6.02 E23. I knew you knew the number, but this is going to be called a formula unit. And to be honest with you, you can use molecules for that too. It's a generic enough term that it'll work. Ding, ding, ding. How many fluorides are in calcium fluoride? Now remember, we talked about calcium fluoride is CaF2. So how many fluorides in calcium fluoride? Well, wouldn't we have twice that number because I have 2 F's in here? So it would be 6.02 E23 times 2. Okay, it's about as tricky as we're going to get. How many times Matt thinks people, so how many moles are in 1 mole, how many particles in 1 mole of times Matt thinks that people eat frog legs? Well, we do all know that, let me erase this so you can see it, that Matt thinks everybody on Earth has eaten frog legs, but that's not it. I suppose in the comment section, if you can say how many times you've eaten frog legs, I'd find that amusing. But the answer for a mole of anything would be 6.02 E23. All right, mass is measured in grams, and little g stands for go to the periodic table. And we've looked at this kind of a lot when we did average atomic mass. So if I have NO, here's nitrogen, here's oxygen, that's the compound. We will always use 2 decimal places, no matter what periodic table you use, we'll pull 2 decimal places, okay? So you have to be able to round to 2 decimal places. I don't think I'm killing you here with that. 14.007 would be 14.00 plus oxygen. See that 15.999? That's 16.00. And that's 30.00. And we're going to call that grams per mole. Okay? So CO2. What am I going to say for carbon? 12.01 plus, now I have 2 oxygens. Watch my, oops, it does like this. Watch my craziness here. I double that. Ooh, 32. Yep, welcome to high school math, boys and girls. We are here, 44.01 grams. Uh-oh, now it gets tricky. Al2C2O4 taken 3 times. Yikes! So, aluminum. Oh no, I have to look at my periodic table and see what aluminum is. Look at your periodic table. It's 26.98 times 2. And then how many carbons do I have here? Well, I have 3 times 2. So I have 12.01 times 6. Sorry I don't have aluminum here, but remember how carbon's 12.01? 6. And then I have 3 times 4, so 16.00 times 16. That's not 16, that's 12. 16.00 times 12. 12 times 6 is 74. Wow, that took me way too long. 74.06. 26.98 times 2. Okay, I'm going to resort to my calculator. 53.96. Oops, I know what my problem was here. This is 72.06, sorry. And then 16 times 12 is 192. I'm going to add all those up, and I'm going to get 53.96 plus 72.06 plus 192 equals 318.02 grams. So that's how many grams are in 1 mole. So if I said how many grams are in 1 mole of NO, 30 grams. How many grams 1 mole of CO2? 44. And aluminum oxalate, that's it. Okay, I'm going to skip SO4 just because I don't want to. Well, the charge doesn't really matter much. So convert 12.5 grams of CO2 into moles. Okay, so what I'm going to do is I'm going to start all the way over here and do 12 point. Oops, I already messed it up. 12.5 grams of CO2. Now, when I do this, this will show you why units are important and how units cancel. Okay, so I hate this unit, grams of CO2, because I want moles of CO2. So I'm going to put grams of CO2 on the bottom to cancel. If you remember from math class, if I have 7 times 2 times 9 sevenths, I'd cancel my sevens, right? So if I hate grams of CO2, I'm going to put grams of CO2 on the bottom. And I'm going to multiply essentially by 1, or if I did this by 7 over 7, right, I'd be multiplying by 1. So I'm going to put moles of CO2. So if these two numbers equal each other, I'll be multiplying by 1. I really wish it would stop doing that. 1 mole of CO2 is go to the periodic table of CO2. So if you recall, I did on the last page, 12.01 plus 32 is 44.01. Notice how that cancels my units. I'm in the units I want. Booyah! 12.5 divided by 44.01 is 0.28 moles of CO2. Okay. Convert 19.9 moles of oxygen to grams. So now I'm going to have 19.9 moles, and this is tricky. Oxygen is not O. Oxygen is O2. It's diatomic. Oh, welcome back after our wonderful holiday. So now this time I want grams of oxygen. So I want to eliminate and kill moles of oxygen. So I put moles of oxygen on the bottom to cancel. Put grams of oxygen on the top. Now, 1 will always go with moles of oxygen for this part. Okay? Ooh, stop doing that. So 1 mole of oxygen is how many grams? Well, I have 2 oxygens here, so when I look at the periodic table, it says it's 32.00. And then I ask my calculator. 19.9 times 32 is 637 grams of oxygen. Boom, bada 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 bada. Now, moles over moles use coefficients. So what we've done before is we started in, say, CO2, and we ended up in CO2. Or we started in oxygen, and we ended up in oxygen. But we get to do chemistry with this now. So notice I'm going to start with this and end up with one of these guys. Ooh. 12.3 grams of KClO3 react. How many grams of O2 will form? So remember, when I do my factor label method, they always have to equal each other. So I'm going to start with 12.3 grams of KClO3. And times dividing bar. Would you stop doing that? Would you stop doing that? Would you stop doing that? I put grams of KClO3 on the bottom, and I want to get into moles of KClO3. So 1 mole, and little g stands for grams, so I'm going to go to the periodic table. So I look at K, I see 39.1, plus chlorine is 35.45, plus 3 oxygens, so plus quantity 3 times 16, or just plus 48. And I got 122.55. So now I've gotten rid of grams of KClO3, but I want grams of O2. Now, I'm now hating moles of KClO3. Moles of KClO3. And remember, moles of KClO3 is basically molecules, right? Stop doing that. So 2 moles of KClO3 will equal 3 moles of O2. So notice moles over moles use coefficients. So notice I got into moles of KClO3. Now I'm going to get out of moles of KClO3. And when I have moles over moles, I have to use the coefficients. Coefficients, remember, are the numbers in front. Times dividing bar. Now, I've gotten rid of moles of KClO3, and now I'm in moles of O2, which I hate. I'm going to cancel it, kill it. And I want to go into grams of O2. Now, you might think, why wouldn't I just put grams of O2 here first? Well, I don't know how many grams of O2 equal moles of KClO3. That's not something I know. It's not something you know either. So now I have moles of O2. Now 1 mole of O2 is 32 grams of O2. Now why isn't it 3? Well, that's a good question. These things have to equal each other. They are equivalencies. Okay, 32 equals 1 mole. If I put a 3 here, I'd have to multiply this number by 3, which is silly and just doing more math than we need. 12.3 divided by 122.55 times 3 divided by 2 times 32 equals 4.82 grams of O2. Now I want to warn you, if you did this on your own, I do these step by step here. If I did 12.3 times 3 times 32, everything on the bottom you divide by. You divide by 122.55. You divide by 2. Tons and tons of people will make the mistake of multiplying here. This is divide. If it's on the bottom, you divide on the bottom. Okay, anytime you're on the bottom, you divide. Okay? If you want to know why, ask your math teacher, ask me in class. I'm happy to talk about it, but just know that's what you do. Chemistry is about doing for the math, not explaining for the math. All right. 4.53 grams of KClO3 react. How many moles of O2 will form? Would you just stop bouncing around? So 4.53 grams of KClO3. And this time I'm going to go to moles of O2. I hate you, grams of KClO3. Now what's a little bit better about this one is I already did the molar mass, so I don't have to add all that up again. I did it earlier, right? It's 122.55. So that's a nice thing about having it be the same problem. So that will kill my grams of KClO3. I'm now in moles. I always have to go through moles. It's my good converting thing. And I want moles of O2. So I'm going to I want to get rid of moles of KClO3 and go into moles of O2. So moles over moles need coefficients because they need an equivalency. I get 3 of these when I react 2 of those. Now I stop there. I don't have to go all the way into grams because that's what the question asks for. Come in. Come in. Hi. Yeah. You want to say hi to the podcast?
I made something for you.
Oh, very nice.
It's the mermaid in the prefix bathroom. Remember the one? I know it
I love it. Say hi to the podcast, Marianne, since you.
Hi.
Happy New Year.
Happy New Year.
Okay, thanks. And when I do all this, sorry about that, I get 0.0554 moles. Okay? Uh-oh, bigger one, different one. 345 grams of SO2 reacts. How many grams of CaCO3 requires? Notice you can convert from one reactant to the other. So let's hop right to it. 345 grams of SO2. Whoa. SO2 times dividing bar. HU grams of SO2 go into 1 mole of SO2. And I go to the periodic table. 32.06 is what my periodic table says for sulfur, plus 16 plus 16, 64.06. And then I'm hating you moles of SO2, and I'm going into moles of calcium carbonate because that's the only thing I know how to do. 2 over 2. I love math. I see these reduce and they're 1 over 1. Yay! Way to go, math geniuses. I love math geniuses in my class. 2 over 2 is 1 over 1. If you wrote 1 over 1, God bless you, you're a wonderful math person. Then I do moles of calcium carbonate, and I go into grams of calcium carbonate. Little g stands for grams, little g stands for go to the periodic table. So calcium is 40.06 in my periodic table, plus carbon is 12.01 in my periodic table, plus 48.00. That's 3 of those. So 40.06 plus 12.01 plus 48 is 100.07 grams. So 345 divided by 64.06 times 100.07 gives me 6410. But what's? Canceled grams of sulfate, sulfur dioxide, canceled moles of sulfur dioxide, canceled moles of calcium carbonate. Oh, grams of calcium carbonate. 6410 grams of calcium carbonate. 15.8 grams of silver nitrate is added to excess barium chloride. Did I get this? Oh, I bet I didn't give it to you here. Whoa. How many grams of AgCl will form? Okay, so this is as nasty as it gets. So if I have AgNO2, and I have 15.8 grams, I'll go ahead and label it like this, is added to excess barium chloride. That means I have all the barium chloride I need. How many grams of AgCl will form? So now I need to be able to figure out what the products are. Well, this is a double replacement reaction. AgCl, right, trade in partners, plus BaNO2. I made a new compound. I'm going to check the charges. Silver is plus 1. Chloride is minus 1. Barium is plus 2. Nitrate is minus 1. Bam. Now I need to balance them. Boop, 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 boop. 2 nitrates, 2 chlorides. Winner, winner, chicken dinner. So now I have 15.8 grams of AgNO2 times dividing bar, and I want to know how many grams of AgCl. So looking for grams of that. Grams of AgNO2. 1 mole AgNO2. And I'm going to go to the periodic table. Silver is 107.90 on my periodic table, plus 14.01 for nitrogen, plus 32 for oxygen, and I got 153.91. And then I'll have moles of AgNO2, and I want to figure out moles of AgCl. 2 and 2. And I do want grams, so I have to go one more step. 1 mole AgCl, canceling that, bam, to grams of AgCl. So 107.9 plus 35.45 is 143.35. And I calculated that out. 15.8 divided by 153.91 times 2 divided by 2 times 143.35 is 14.7 grams AgCl. Boom. Extra credit, 10 points in your homework. Woohoo! Make a mole with a bad pun. Sew it and stuff it and have some pride. Here's a website that shows a picture of it. I hope you do it. It's fun. We'll have a mole parade. That is it, I believe, kiddies. So moles are groups of of particles or anything that are 6.02 times 10 to the 23rd. Molar mass, go to the periodic table in grams. That's the mass of 1 mole. Converting through moles has an equivalency called the mole ratio. And that's it. Toodles. Happy New Year.